In this video, we're going to teach you how to install the QRail racking system onto a rooftop. Download and read the most current installation manual in addition to referencing this video. We will demonstrate here using a conventional 2-rail configuration. QRail can also be used in shared rail and modified shared rail configurations. There are two options for designing a QRail system. You can design online using QuickMount PV's free QDesign software, which can be found at qdesign.solar. The application will quickly provide you with a complete engineering report and a detailed bill of materials. You can also design the array by referencing the code compliance certification letters, which are available at our website. QuickMount PV reminds you that safety on the roof always comes first. Check the OSHA website to ensure that you are properly utilizing fall protection equipment and that your fall protection anchors are properly attached to the roof. QuickMount PV recommends that you assess structural considerations and local requirements before ordering QRail. In particular, acquaint yourself with applicable wind speeds and snow loads, the roof structure and any irregularities, dimensions, material, quality, and spacing of the rafters, and the proper attachment method for the roofing system. After considering these factors, to determine the roof attachment locations, you will need to take into consideration the following metrics. Rafter locations and aesthetics will determine where you will fasten a mount to the rooftop. The roof attachments must be installed at defined distances based on the position of the array on the roof, module orientation, the spacing of the rafters, and module clamping zones. The allowable racking cantilever dimensions must not be exceeded. The cantilever is determined by measuring the distance between the mounting point of the outermost roof attachments and the end of the rail. They are based on 1/3 of the allowable rail span for the site conditions. They can be found on the span tables and on the QDesign engineering report. Module clamping zones are provided by the specific module manufacturer and are used to determine the vertical placement of the rails. The overall dimensions for the array are based on the height and width of the module field, including the distance between the modules. The QRail system utilizes a 17 mm gap between the modules and a recommended 1/4 inch gap between module rows. With the array location and dimensions calculated, mark off the mount locations and cantilever zones on the rooftop. Make sure that you select a shingle course that lies within the module clamping zones. QRail is available in light and standard versions and ships in 14-foot and 17.3-foot lengths. Depending on your array design, you may need to use a splice to connect an additional length of rail. The internal Q-splice is a structural, bonded splice that installs in seconds and requires no tools or screws. There must be a minimum of 2 mounts on both sides of the splice location. An exception to this rule for the interior of the array can be referenced in the code compliance letters. To install, simply insert the end of the internal Q-splice into the end of the QRail. Make sure that the integrated bonding plate slides into the rail, and then slide the splice until the bonding plate tabs come into contact with the end of the rail. Now attach the second segment of the rail to the other side of the splice using the same procedure. Make sure that both rail ends are tight against the bonding plate tabs. To allow for thermal expansion and contraction, spliced rail lengths must not exceed 45 feet without a thermal break. Temperature variations in other structures, such as metal buildings, may result in increased or decreased thermal break calculations. If this is the case, site-specific calculations may be used in place of a 45-foot thermal break. In cases where a thermal break is necessary, it is recommended to use the splices in conjunction with a braided bonding jumper to ensure continuous bonding across the thermal break. After installing the rails, insert an internal splice, leaving a 3/4 inch gap between the rails. Install the bonding jumper across the gap with T-bolts and torque both sides to 16 foot-pounds. Never install modules over the thermal break. QRail can be installed on any pitched roof surface and is compatible with any roofing mount that utilizes an L-foot. The entire system can be assembled using a single half-inch socket driver. In this video, we will feature our economically priced low-profile L-mount installed onto a comp roof, as well as our popular tile replacement mount installed onto a flat tile roof. Select a roof attachment of your choice and follow the roofing manufacturer's instructions for fastening the mount to the rafter. It's a good time-saving tip to prep the L-foot with the T-bolt. This will prevent having to fumble for small parts that may fall off the roof while the rail is being installed. With all of your mounts installed, the rails can be lined up on the roof for installation. It is highly advisable that the rails are either left or right justified, as this will assure that you are only cutting the rail on one end. With your L-feet prepped and your rails squared, it's now time to attach the rails to the L-feet. T-bolts are used to attach the QRail to the L-feet, eliminating the need for preloading the bolts in the rail. When attaching the QRail to the L-foot, make sure that the serrated side of the L-foot aligns with the serrations on the side of the rail. To attach the QRail to the L-foot, insert the T-shaped head of the bolt into the channel on the side of the rail, with the head aligned horizontally so that it can easily enter into the channel. The T-bolt is fully engaged when the head of the bolt is rotated to a vertical position. The imprinted line at the base of the bolt indicates the exact position of the bolt's head, so it's easy to line up even when you cannot see the bolt head behind the L-foot. Loosely attach the rail to the first and last L-foot in the row. It is now possible to adjust the rail's position to the desired height by moving the T-bolt up or down in the L-foot slot. You will likely be fine-tuning the position of the rail, so do not torque down the bolts at this stage. Then, continue working your way across the roof installing the remaining rails, splicing where necessary. It is important to make sure that rails are properly squared. When rails are not squarely aligned, modules can become skewed as they are installed. There are proportional measurements that can be made to assure your rails are perfectly squared. Since diagonals of a rectangle are always equal, you can measure in from the edge of two rails and then compare the measurements of the diagonals to perfectly square up the rails. Another method involves calculating the proportions of a 3 by 4 by 5 triangle. When each row of rails has been installed, use a straight edge or an additional piece of rail to determine that the rows are consistently level. If necessary, loosen the T-bolts and raise or lower the rail. With your rails installed and squared and adjusted for height, secure the QRail in place to the L-foot by tightening down a serrated nut to 16 foot-pounds using a ratchet with a half-inch socket. It is also possible to use a drill with a clutch setting and then finish tightening down the nuts with a torque wrench. End caps add a nice aesthetic to the overall look of the finished array, as well as prevent critters and debris from entering the rails. End caps have 4 pins. The bottom of the end cap is indicated by the set of pins that are closer together. Install the end cap by inserting the bottom set of pins into the end of the first rail and then rock it up and insert the top set of pins. The end cap will securely lock into place. To ground the system, you will need to install a QMR GLQ grounding lug into the channel on the QRail. One grounding lug will need to be installed to each array segment in order to ground each row of modules to each other. The pre-assembled QMR GLQ grounding lug consists of a lug, a T-bolt, and a wire capture bolt. The grounding lug can be installed in the top or side channels of the QRail in any orientation. To install the grounding lug, insert the T-bolt into the desired channel on the rail and tighten the grounding lug in place with the T-bolt to 16 foot-pounds using a half-inch socket. Attach your copper grounding wire to the wire capture bolt and torque to 7 foot-pounds using a half-inch socket. The rule of dissimilar metals applies here, so take care that the copper wire is not making contact with the aluminum QRail. Attach the other end of the copper wire to the installed grounding lug in the next array. Module-level electronics are typically attached to the rails and wired before the modules are installed. Optimizers and microinverters can be attached to the top of the rail using a standard QRail T-bolt. Tighten the bolt down to 16 foot-pounds. Whether you are using module-level electronics or not, you will need to secure wires to the rail. The QRail system allows for wires to be attached to the rail with wire clips that clip into any of the channels on the rail. QRail features a fast-installing stainless steel wire clip that can fit 1 to 3 PV wires. The clips respond to tension, so pulling wires through is quite easy. Squeeze the wire clip and insert one hooked end into the channel and then rock in the other hooked end. The clip will click into place. When securing a single wire, the clip can be pushed in past the flanges on its sides, clicking in and staying secured at a smaller gauge. Follow basic wire management strategies to secure all of your PV wires and home run wiring to the QRail. Modules are connected to the rails using end clamps and mid clamps. The mid clamps are fully bonded, and the 30mm to 45mm clamp range fits nearly all module frames. A 38 to 50mm clamp range is also available. The clamps require no pre-assembly or preloading. Before installing, simply check the clamp to make sure that the bolt is positioned above the inside heel plates. It should be positioned like this right out of the box, but it may have adjusted slightly during transit. If the bolt is positioned too low, it will prevent the Q-click from properly engaging in the rail channel. Simply spin the bolt up so that it sits above the inside heel plates. To install, angle the end clamp slightly and insert one of the hooks at the bottom of the Q-click into the channel on the top of the rail. Then simply rock the second hook into the channel. The clamp will click into place and then remain self-standing. Grasping the installed clamp at its base will allow you to easily slide it in the channel. The pre-assembled universal end clamp consists of a lower clamp body and an upper clamp body. The upper clamp body is movable and allows the clamp to accommodate a range of module frame sizes. With the end clamp securely clicked into the top channel of the QRail, slide the end clamp flush against the edge of the module frame. The upper clamp body should be flush and engaged with the serrated edge of the lower clamp body. The lower clamp body should sit squarely on top of the rail. The QRail must extend beyond the edge of the module frame by 1.2 inches at each end of the array. Firmly holding the upper clamp body against the module frame and flush against the lower clamp body, tighten the clamp bolt to 8 foot-pounds using a 1/2 inch driver. Take care not to over-torque. The lip of the upper clamp should be flush against the module frame. Do not tighten down the clamp bolt using an impact driver. The end clamps generally do not require a bonding plate unless the module is standalone or is not connected to any other module using mid clamps. In this case, an optional weeb clip can be attached to the upper portion of the clamp. The weeb clip simply slides on and clicks into place. In this situation, one end clamp per rail will need to be equipped with a weeb clip. However, redundancy is permitted. The pre-assembled universal mid-clamps feature integrated bonding pins, so grounding is fully achieved with multiple redundancies. The universal mid-clamp clicks into the channel on top of the rail in the same manner as the end clamp. Slide the installed mid-clamp in the channel by grasping it at the base and position it flush up against the side of the module frame. Ensure that the clamp head is resting on top of the module frame. Slide the module in the next row into position under the clamp head. After checking to assure that both modules are pressed flush against both sides of the mid-clamp, tighten down the clamp bolt to 12 foot-pounds using a 1/2 inch driver. Take care to not over-torque, as this can affect the grounding. Do not tighten down the clamp bolt using an impact driver. The QRail hidden end clamp offers an aesthetic solution by allowing the modules to be installed flush to the edge of the rail. To install the hidden end clamp, simply slide it into the top channel at the end of the rail and position it 4 inches in. Lay the module down so that the frame is flush with the edge of the rail. Slide the hidden end clamp over until it fully engages the module flange. Tighten the clamp bolt to 9 foot-pounds using a ratchet or a right angle tool. When you are installing the hidden end clamp to the last module in a row, it is advisable to lay the module in place to find the end of the row. Then mark the edge of the module on the rail. Remove the module and cut the rail at the marked location. This process is suggested to avoid having to cut the edge of the rail flush with an installed module, which can damage the module frame. It is also possible to utilize the QRail rail cutting guides to protect the module frame. With the QRail cut, install the hidden end clamp and tighten it down to 9 foot-pounds. As you lay down each module, make sure to connect the PV wires to any microinverters or optimizers you may be using and then connect them to the next module in the string. Keep the wires from sagging by clipping them to the QRail or to the module frame where necessary without pulling them too tight, since there will be ongoing thermal contraction and expansion. NEC requirements also stipulate a minimum bend radius, so tight coiling or bending is not advisable. In no case should wires be less than 2 inches from the roof surface. Rails are cut to fit the measured length of the array plus allowance for end clamps. This usually occurs before rail installation if the installation is a simple shape with no obstructions. Rails are also sometimes cut at the end of the job once the requirements of the array have been met. Rails are commonly cut using cordless band saws or reciprocating saws. When cutting the rail, take care to make a square cut for best aesthetics and to ease the installation of the end caps. Quick Mount PV offers rail cutting accessories that slide onto the rail to both protect the edge of the module frame from being scratched while cutting and to provide a guideline for a square cut. The Q skirt attaches directly to the front edge of the module frames. A Q-click channel in the skirt allows for installation using the same mid and end clamps used for the rest of the array. Torque the end clamps down to 8 foot-pounds and the mid clamps down to 12 foot-pounds. The length of skirt needed will typically be the same length as the first rail. Splices should be installed prior to fitting the skirt to the array. For more information on the QRail system, download our detailed installation manual, and please do not hesitate to reach out to our Tech Services department with any questions.